Okay, our last video was pretty easy. We were just seeing that roots work exactly like variables, and if you want to combine them, they have to be exactly the same name underneath the root, exactly. Now, we're going to get some more difficult ones here, and all we're going to do is we're going to use the skills that we'd learned earlier in the chapter to simplify them first in order to see if maybe they are the like terms that can be combined. So they've done square root of 20 here, and now they're doing their method where they found a perfect square. But so they simplified them, and now look what they've found. These do match, so we can add them up. So that's all that's changed. We're going to simplify anything that needs to be done. And so I'm going to jump here because I'm just going to get to the end. If you want to do it by the other method, that is totally fine. So I'm just going to get it. There's a whole lot of these. So this would turn out to be 3 square root of 2 plus 6 square root of 2. If we put that together, it'd be 9 square root of 2. They're the same thing. We can combine them. Okay, you can break down 27, and this is what you'll get. Those are the same thing. So I've got 7 square root of 3. All right, now what's happened here is we just have 2 that we have to break down. So I'm going to let them do this for us. We get down to this. Those are the same kind of thing. 4 minus 5, it's like negative 1, but you could just say negative square root of 3. Okay. Okay, I'm jumping ahead, but if you use our tools from the previous lessons, you'll get to the same place. These are the same kind of thing, and I've got 1 square root of 2, which is just, I'm going to just write it as square root of 2. So 4 minus 3 is just 1, and that's the name of the term, the square root of 2. Okay, again, I'm jumping ahead here. I'm not going to show them all again. We've got those videos. But so if we put these together, we simplify them, we have like terms. So we've got negative 1 square root of 5, which you can just write as negative square root of 5. All right, we're going to see some variations here that we already have something in the front here. So when we simplify, I don't know if we've seen that very often. So here's what would happen. If you break down, let me do that one. Okay, so I'm breaking down, let's get rid of their stuff. If I'm breaking down 18, I'd get this. So I can pull out a 3 because they match up, but there's already a 5 out there. So what you do is you multiply that 3 that comes out with the 5, and you'd get 15 square root of 2. Now the same on the back end, they can pull a 2 out of there, but there's already a 2. So I'd get a 4. So you got 11 square root of 2 because they're the same thing. You can combine them. Okay, if I break this one down, what I'm going to find is I can bring out a 3, but there's a 4 out there already, so that's going to be 12 square root of 3. Now over here, I could be able to bring out a 2 is what you're going to wind up being able to get out. There's already a 3 outside, so that's going to be 6. Now they'll match. Okay, same thing again. The perfect square that I'm going to pull out. You could do it to the old method. I know I keep saying that, but you could pull a 2 out. That would get you 6 square root of 5. On the back end, you can pull out a 3. So I'm going to get negative 21 because I'm multiplying the 3 by the 7 square root of 5. Okay, they're the same thing, so they can be combined. Okay, these are just getting more and more complicated. The fractions are out front, but we're just going to see whatever can be pulled out is going to be multiplied by a fraction. So they're pulling out an 8. Okay, well 8 times 3/4, you can cancel the 4 and a 2. You get 6 there. So that's all. You can pull a 6 out of the back one. It cancels with the 6 on the bottom of the fraction. And you get 6 square root of 3 minus 5 square root of 3. That's 1 square root of 3. Okay. All right. So I got to see what we can take out of there. 9. Okay, I'm doing their perfect square approach here because I don't want to break all the numbers down. And I was getting some hints from what they were doing here. But so if I break this down, I can pull a 3 out of there, and I would be left with 12 on the inside. Yeah, I see. I see what I've done. Okay, so I'm going to break this down the whole way. Okay, so if I broke this all the way down, what can come out of here is a 3 and a 2. So I can bring out 3, I can bring out 6. So let me write this over. So what comes out of there is a 6. I've got a 3 left on the inside. On this back end, I can bring out a 7, and I'm left with a 3. Now let's simplify those fractions. I can multiply 3 and 2 can reduce. So 2 times 2 is 4 square roots of 3. On the back end, the 7's will go. I get negative 5 square root of 3. Now these are like terms, so I get negative 1 square root of 3, or just negative square root of 3. Okay, again, I'm just going to jump ahead if I see them. I'm pretty sure what you can bring out of there. No, I'm not right. There's a bigger one. So what you could bring out of 200 would be okay. So what you could bring out of here is actually you could, oh yeah, of course, you could bring out 10, and you would be left with a 2 on the inside. Oh, I have no idea. On 128. Oh, that breaks down a lot of 2's. Okay, so okay, if I did that right. Okay, I can bring out 2, 4, 8. And this other one, I can bring out an 8 and be left with a square root of 2 on the inside. Okay, we're going to reduce these down. I get 6 square root of 2. Reduce these down. Get negative 3 times 2, negative 6 square root of 2. Okay, if I did that right, we're going to get 0 square roots of 2, which is just 0. All right, I don't know what, let's jump ahead and see what's different about this. So they have reduced these, and we get here. Yeah, and then nothing really reduces. So that's all they've done. Is that, so they broke it down the same, but we don't have anything to reduce. So we're just going to get a much more complicated answer that has fractions in it. So what are they doing? Oh, okay. They're getting a common denominator here. They're just working with the fractions. Suppose you just had 8 thirds minus 3 halves. Well, what would you do? You have to get a common denominator, and if you change the denominator, you got to change the numerator, and you get all that down to this. Let's really do one here, and hopefully you'll get the idea. So again, I'm not showing all the breakdown if I can avoid it. Some of them I don't see. Okay, so here I've broken them down. Now, there's no reducing that can happen, so I'm going to have 8 fifths square root of 2 minus 2 thirds square root of 2. Now, I have like terms, but these fractions are not finished, so I'm going to come over here and do this. This is what I'm trying to do. Now, I would turn those both over 15. I got to get a common denominator. Slices of pie have to be the same. So multiply the top and bottom by 3 on that one. This one, both sides by 5. And I would get 14 over 15. Okay, so 14 over 15 square roots of 2. Kind of strange, but there you go. Okay, hold on. I'm going to see what we've got here. All right. I don't know what's coming. But we got more of these, so let's do this. So 80, let's see. I don't see that off the top of my head. Okay, I'm using their idea a little bit. I'm going to be able to bring out a 4 and have a 5 left inside. On this one, I'm going to be able to bring out a 5 and have a 5 inside. Okay, again, I'm doing the fast way, but you could do the long way. All right, so I get 4 thirds square root of 5 minus 5 fourths square root of 5. Now, those are like terms, but the denominators of those fractions are not the same, so I'm going to fix that. I'm going to put them both over 12. But if I multiply the 3 by a 4, I got to do it to the top. 4 by a 3, I've got to do it to the top. Okay, so if I just get those fractions together, I get 1/12 square root of 5. Okay, now the only thing that's changed here is we now have idle knows that we have to pull out as well. Now this is going to get a little confusing. I'm going to jump all the way here. So they just simplified these. We know how to do this. Now look what we have. Now what's very confusing is that, so let me write one of these. All of that is the name of the team. All of it. It's the n squared square root of 2n team. It all has to be exactly the same if we want to combine them. Now it's true, it is here. I've got 3 of them here minus 4 of them here. But so I put that together, I have minus n squared square root of 2n. So this is getting very crazy, but anything with the variables and the roots together is the name of the team. So let's do this here. And again, I'm going to jump to what you would get on the outside. Okay, now I've simplified them rather quickly, but this is what you would get. Now, all of that is the name of the team. Now, it's a match. It's an exact match. So all of that is like a big word. The English word matches. I can put them together. I get -1. And that's it. Oh, those are M's in there. Sorry. And that's my answer. Okay, we try another one here. Okay, this is all the name this time. Very long, but it is a match. The word is the same, so I've got negative. Now, I didn't show the 1 this time. I just showed it as a negative. Okay, I don't know what's going to get twisty here. Let's see. So I'm going to let them reduce it for us. Oh, not much. The only thing they did is that there was already stuff out there, so it combined. So we brought out a 9, but there was already a 5, so that made 45. We brought out a 4, but there was, we brought out a 5 here. There was already a 9. We brought out a 4, there was already a 6. That's all. So just, we saw that earlier, that if you bring that out and there's already a number there, you're just going to multiply them. Oh, okay, there's more here going on. So look at the names of the teams. I've got m square root of 2 and m square root of 3. Those are not the same. So after I simplified them, that's the best I can do. That is not the same word, so I cannot combine them. So I can bring a 4 out of here, and you can do it the long way to see it, but I can bring out a 4, there's already a 5, so I get 20. I can bring out an x. What's left on the inside would be 2. Now over here, I can bring out a 4, and there's a 3 on the outside, I get a 12, and I can bring out an x too. Okay, so you simplify them if you don't see where I'm going with that. But look what I have now. The name of this team is x squared root of 2, the name of this is x squared root of 3, they don't match. So that's the best I can do. Okay, we'll see this again. Pause it if you want to try it without some help here. I can bring a 4 out of here. So I get 28, and I can bring out a y. Over here, I can bring out a 6 and a y. Okay, so check yourself on tidying those up. But the team name is y squared root of 3. This one's y squared root of 2. They don't combine. Okay, so we just have a bunch of them in a row now. So I'm going to let them tidy it up for us. They tidy them up and we get down to this step right here. Now look, the names are all the same. X squared root of 2, x squared root of 2, x squared root of 2. So these can combine and we would get this. Okay, so I'm going to go quickly here on the reducing part. Check yourself. I can bring a 4 out of here, or yeah, I can bring a 2 out, so that would give me a 6, and I can bring out an x. Leaves a 3 on the inside. On this one, I can bring out, let's see, hold on, I don't see it. Okay, I can bring out so they'll partner and they'll partner. I can bring out 4, so I get minus 8x square root of 3. So far I got matches. Let's see this last one. I can bring out an x and a 3. Okay, so check me on that tidying up, but this is what I think you get. The names of these are all the same. So I can combine those, and I should get 10x square root of 3. That's the name of the team. Okay, I want to see how many we got of this. All right, I can bring out a 3 out of this. I'm going to get an n and x. So bring out the 3, joins the 3, multiply them. I get 2 in there. I can bring a 4 out of here. There was already a 6, so that's going to be negative 24x. And out of this last one, I can bring a 5, which is going to multiply to get a 10, and I can bring an x. Okay, so these matched up. Remember, all of that craziness is the name of the team. All right, so I put these together. I've got 19, get minus 5, x square root of 2. Okay, I know it's confusing, but that's really all that's going on. We just keep simplifying, and the key is, can you combine them if the team is the same? Any variables or radicals on the end are all the team name.